So hey guys, again we are back with one more numerical. Okay, so which is based on again the settling time, rise time, and all. So here the control system is given. Find the values of k and kt. Kt, script t. Kt is here, k is sitting over here. We have to find that value so that damping ratio of the system is 0.6. Damping ratio zeta value is 0.6, and the settling time is 0.1 seconds. Now they have said us that you can use the TS value, the formula as 3.2 by zeta omega n. They have already mentioned in the question, and also they have said that assume the input as step input, unit step input. Assume unit step input. Okay, so this all things they have already mentioned. This is the question, so we have to find k and kt value, and some given things are already. Now let us proceed. First thing, always remember, first always you have to find transfer function. They have not given directly the transfer function, so transfer function is not given, which is nothing but c of s by r of s. It is not given. So what we have to do, we have to find out c of s by r of s. For that they have given the circuit. For that they have given the figure. So for that what we can do, we can go by block reduction method. Yes, I hope you have seen that videos also, so we'll try to understand here. Now here if you see this first thing, the blocks, you have to find whether series or parallel blocks are there or not. Okay, so there are no series or parallel blocks. Now second step is that we have to go for what, minor loops. So here you can see one minor loop is sitting. Okay, if you're not understanding, kindly see that videos and come. But for this question I'll just explain. Now always remember these two are not in series, because here one takeoff point came. Okay, so that is not series, and this block and this block also are not in series, because summing point is there in between. That's why they are not in series. Parallel anyways it is not there. Don't think that these two blocks are parallel. These two blocks are basically feedback. This is a feedback block, so these two will be what, a minor loop. They are called loop. No, they are not parallel blocks. Loop. Okay, they are in a loop. Direction, you can see, I'll just draw the direction. Input to output, this is the direction, and feedback is always opposite to this forward path. Okay, that's why it is called as loop. Now this loop, can I reduce? Yes, I can reduce. How to reduce this loop? Can I write this loop as, so I'll draw this one. So r of s is sitting here, then one summing point is there, then k block is there, right? K block, then this block, entire block I am reducing it to one block. How to reduce that? Always remember, when you reduce the loop, it is nothing but, how to reduce that loop, you have to introduce a new block. In that you have to fill it with the transfer function. How to write? Okay, for minor loops, so that will be g of s by g of s by 1 plus or minus g of s into h of s. This is what you have to do. G of s is the forward path gain, and h of s is nothing but the feedback, which is nothing but here kt. Now g of s, what is g of s? It is nothing but 100 by this thing. So can I write g of s as 100 by 1 plus 0.2s, this is g of s, divided by 1 plus or minus. Now which sign I should put? Here you can see, when I go for forward feedback path, I am getting the summing point sign as minus. So always you have to take the opposite sign, that is nothing but plus. So I should take here 1 plus, not minus. So 1 plus, again g of s, this is, which is nothing but 100 by 1 plus 0.2s into, what is h of s? H of s value is kt. H of s value is kt. So I have completely made a new block by reducing that minor loop. Now what is sitting over here? Here it is 1 by 20s, right? And output will be, okay, output. And one more feedback is there from the output to this summing point. So I hope you understood what we are trying to do. So what we can again reduce this one. So r of s, this block can I simplify? So r of s, then one summing point, then one k block is there. Can I reduce this one? This one, can I write it as 100 by 1 plus 0.2s is there. It will be 1 plus 0.2s. Denominator can I write it as, take LCM. It will be 1 plus 0.2s. Just multiply this with 1. 1 plus 0.2s plus 100 into kt is 100 kt divided by 1 plus 0.2s. I hope you understood. Now this and this will get cancelled. Now what is remaining? Only this and this is remaining. Can I just directly write that answer? So I'll just eliminate part. Directly I'll write this. So it will be 100 divided by this one. Okay, so I hope you understood the LCM part also. Now here, what is left out? 1 by 20. Output is there. Of from output 1 feedback loop. Okay, here sign, be careful, minus sign is there in the question, just mark it. Now here you can see that this block and this block and this block, they are indirectly connected. There is no summing point, takeoff point between them, right? So can we say that those three blocks are in what? Series. So whenever series blocks come, what you have to do? We have to just directly multiply. So I can just directly multiply with that. So let us see that multiplication. R of S on summing point, then this entire thing I'll just write it in. So k into 100, it will be 100k. Then 1 by 20s we have to multiply, which will be in the denominator. So 20s will be there, and 1 plus 0.2s plus 100 kt will be there. So I hope you got it. And output is already there. But C of S, from this output we have taken one feedback connected to this summing point with minus sign there in the question itself. So I have reduced this just multiplication, this block into this one, that's why 100k came. Then 1 by 20s was there, that's why I multiplied. 20s will come below the denominator part. So this also we got. Now we have to simplify this one. So how to simplify? Can I cancel 20 ones-a, 20 5s-a, right? I can cancel that also. So what will be my final thing? Final, we can reduce this. So I'll directly write over here itself, draw again. So directly you reduce and just write off here 5k, and this will be 20 is cancelled, only just s will be remaining. Complete the, that's it. Okay, now here again one loop came. This will be the final thing, right? Block reduction rule is basically says that this is the final loop we are remaining. Here there is no gain, right? Earlier we had what? Gain as kt. Here there is no gain. So if a gain is not there, you have to take it as what? 1. Basically unity feedback. Okay, you have to take it as 1. Now again you have to apply the same concept. Here also loop came, that means g of s by 1 plus or minus d of s into h of s you have to apply. What is h of s here? H of s is 1. What is g of s? This entire block. Again I'll apply. So this will be the final thing. That means this you will get it as what? C of s by r of s. So C of s by r of s is nothing but these two we have to solve. That is nothing but g of s. What is g of s value? 5k divided by s into 1 plus 0.2s plus 100 kt, right? This g of s divided by 1 plus or minus. Which sign I should use? Here minus is there, I have to use plus. Plus g of s again came, that is 5k divided by s into 1 plus 0.2s plus 100 kt, okay, into h of s. H of s is nothing but 1. This is the final thing we are getting. Now we have to simplify this again, right? When you simplify, let us see what happens. So it will be 5k divided by s into 1 plus 0.2s plus 100 kt whole divided by, now can I take LCM? So 1 you just multiply, it will be s into 1 plus 0.2s plus 100 kt plus 5k whole divided by s into 1 plus 0.2s plus 100 kt. I'm just taking the LCM. Okay, I hope you understood. LCM basically means here 1 is there, denominator nothing, so it will be 1. Here this guy is sitting, so just multiply with this one. That is nothing but LCM. Now here, can I cancel this entire thing and this entire thing? Yes, you can. Now what is left out? Left out is basically 5k whole divided by s into 1 plus 0.2s plus 100 kt plus 5k, right? This we are getting. This is nothing but CFS by RFS. Can I open the bracket? Right, you can open the bracket also. So let us open the bracket. It will be 5k divided by s into 1 is s plus s into 0.2, that is 0.2 s square plus 100 kt into s plus 5k outside the bracket. Okay, so again from this, can I take s common, because here also s is there, so I can write it as 5k 5k whole divided by s square. I'll write first 0.2 s square plus s I'll take common, so it will be 1 plus 100 kt, right, plus 5k. Okay, so I hope you understood. From this two I have taken s common, so s into 1 is s into 100 kt is 100 kts. Okay, so that's why I have taken s as common. Now this part is also done. So this is the final CFS by RFS transfer function, what we needed. Now after getting this transfer function, what we have to do, we have to compare, we have to find what we need to find the rise time, sorry, not rise time, we have to find the values of k and kt by using what damping ratio is given, settling time is given. So what we can do, we can first find damping ratio. Okay, so we'll compare this one with damping ratio is given, but we'll compare this one with the standard equation. What is the standard equation? Standard equation of second order system we are having, which is omega n square. Okay, omega n square divided by s square plus 2 zeta omega ns plus omega n square. This is standard equation. Standard equation, just compare it with this one, you will get to know that omega n square value is 5k, right? Omega n square value is 5k here, but one problem is there. Here 0.2 s is sitting, but in standard equation coefficient of s square should be 1. Okay, should be unity. So we can write that coefficient of s square should be 1. So therefore what we can do, we can just directly divide the entire equation, numerator as well as denominator, with what? 0.2. So dividing the entire equation with 0.2. Okay, so dividing the entire equation, numerator as well as denominator, both the things you have to divide. So what will happen now, let us see. So basically we are having the transfer function, so we have to divide 5k is there, divide with 0.2 whole divided by 0.2 s square divided with 0.2 plus s into 1 plus 100 kt divided by 0.2, then plus 5k divided by 0.2. Yes, whole thing you have to divide. So 5 by 0.2, what is 0.2? 0.2 you can write it as 2 by 10, or we can write it as 1 by 5, right? 0.2 is 1 by 5, so 5 will go up, it will become 25k whole divided by, otherwise you just calculate 5 by 0.2. What is 5 by 0.2? 5 by 0.2 is nothing but 2 by 10, so it is nothing but 1 by 5, and 5 divided by 1 by 5 is nothing but 5 into 5, which is 20. Yeah, that also is, so anything is fine, just put it in the calculator and do that. So 25k you got. Now here also it is the same thing, that we'll write afterwards. This 0.2 will get cancelled, so that's what we needed. So it will be s square plus, here 0.2 is sitting, 0.2 is nothing but 2 by 10, which is 1 by 5, so here it will be 1 by 5, that 5 will go up, so it will be 5s into 1 plus 100 kt plus, here this part is same as this part, so it will be 25k, it will be 25k. Okay, so I hope you understood the part. Okay, now let us now go for, this is the transfer function, simplified transfer function. Now this transfer function is correctly in the standard form. Now we have to compare this standard equation with the standard form, which is nothing but omega n square by s square plus 2 zeta omega ns plus omega n square. So remember that this and this will be same. Here also you can see 25k 25k. So can I write it as comparing what will be getting with the standard equation. So we can get that omega n square value is equal to 25k, right? Omega n square value is equal to what? 25k. So from that, can I get omega n value? So omega n is equal to square root of 25k. Now what is square root of 25, which is nothing but 5? Square root of 5 is remaining. Okay. Second thing, we can compare the middle term, which is nothing but, there is no need of comparing a square, it is already coefficient is 1. So middle term is nothing but 2 zeta omega ns. Compare it with the middle term here, the complete middle term, 5s into 1 plus 100 kt, right? From here s and s is gone, so what is left out? Here already we know omega n value, right? Omega n value, can I substitute? So here 2 zeta into what is omega n value, that is 5 into root k is equal to 5 into 1 plus 100 kt. Now from this, can I get zeta value? 2 into 5 is 10, so 10 root k will go there. It will be 5 into 1 plus 100 kt divided by 10 root k. So I hope you understood this part also. Next, what we can do? Can I just simplify again, or otherwise you can cancel 5 and 10, you can cancel and write it as 2 also, otherwise you can leave it here also, that is also fine. Now next thing is that in the question it is given, what is the given data? The given data is nothing but the the damping ratio is 0.6, that means zeta value is given, and settling time is 0.1, and that settling time formula we have to use this one, that will collect and put it over here. So zeta value we got in some form, right? Now we already know, that zeta value is 0.6. Don't need to write, we know that it's given in the question. Zeta value is 0.6 and ts value is 0.1 second, and also they have said that ts you have to take it as 3.2 by zeta omega n. This is the formula we have to use. These three things you have to consider. Now what I'll do, I'll substitute this ts value here. So ts is equal to 3.2 by zeta omega n. In this ts value you already know, which is 0.1. So 0.1 is equal to 3.2 divided by, now here also you know zeta value, which is 0.6. It will be 0.6 into omega n. From this, can I get omega n value? Yes, you can get omega n value. So this you bring that side, it will be omega n is equal to 3.2 by 0.6 into 0.1. When you put it in the calculator, you'll be getting it as 33.33 radian per second. Okay, this is the omega n value. So after getting omega n, what we can do, the omega n value we already got it as what? See here, which is 5 root k. From that, can I get the value of k? Yes, you can. So this you mark it as first and second equation. Yeah, this is first equation, second equation. This two is very important. From that only we can get the value of k and k. Omega n value you got. Now substituting omega n value in first equation. Now what is first equation we are having? We are having first equation as omega n is equal to 5 root k. Now we know already omega n value, which is for this one. So we can substitute 53.33 is equal to 5 root k. 5 will go down, it will be 53.33 divided by 5. is equal to root k. So from this, can I get the value of k? You have to just take square root there. Square root of 53.3 by 5 is equal to k. When you substitute in the calculator, you will be getting k value as how much? 113.78. Okay, so this is the answer for k. Now we have to get kt value also. For that, we are having second equation. Can I substitute there? Yes, you can. Zeta is equal to this. You have to substitute. I'll take it here. Now zeta value already know, which is nothing but 0.6. It is given in the question. So 0.6 is equal to 5 into 1 plus 100 kt divided by 10 into root k. What is root k? Root k value? Okay, fine. So k already we have. This is the value for root k. When you divide this thing, you will be getting as root. That value you have to substitute. Okay, just divide and just substitute. So from this, can I get the value of kt? Yes, you can get the value of kt. Just simplify, you'll be getting kt value. If you want, I'll just simplify also. Okay. 0.6, just multiply this into this. It will be 10 root k equal to, open the bracket, 5 into 1 is 5. 5 into 100 is 500 kt. Now it will be 0.6 into 10 is 6 root k. Then you bring everything this side, minus 5. Then 500 will go down. 500 equal to kt. Then you can substitute root k value, then you can get kt value. So what is kt value? Kt value is equal to 0.118. We are getting value as 0. So I hope you understood the very only thing is that only difficult part is that you have to get reduce the form, apply block reduction method and get the transfer function first. After getting transfer function also, then we simplified because the s square coefficient was not matching with the standard equation. Coefficient always should be 1. For that, we divided whatever was the coefficient. Here 0.2 is sitting, means 0.2 is divide. The entire equation we divided, then we got the transfer function. That is the important steps you have to consider.